All right, I hope you were able to get a formula sheet. I think you all have one, and if not, just Google Math 30-1 formula sheet and you'll find it. I just snipped out what the relevant part was to illustrate what we're doing. I want to show you one thing though. If I have an identity that looks like this, I can assume that this is also true. So you can just write that right on your formula sheet, and this works for all of them. We can square both sides, and it works for this one. And it works for this one. And it also works for this one. And it's going to help us in proving. But we can't mess with any of these with squaring both sides. All right, so class example number 3 asks us to rewrite the following in terms of sine x, cos x, or both. So the first thing I'm going to do is I'm going to take this tan x and I am going to replace it with sine over cos. So this becomes sine x over cos x, and then it's all over sine x. Now I can never leave a fraction within a fraction, so I'm going to simplify that. Get a different color here. So that is sine x over cos x divided by sine x, and then I can leave that as sine x over cos x and take the reciprocal of this one because this is over 1. And what happens now is these two simplify, and I'm left with 1 over cos x. All right, and this is a little bit of a, like, hey, where's Waldo kind of situation here. So we look at 1 plus cotan x, and I see it right here. So I can replace that with cosecant squared x, and this is all over cotan squared x. So what I can do now is I can take this cosecant squared x and I can replace that with 1 over sine squared x, and it's all over, and we know that cotan squared x is equal to cos squared x over sine squared x. And I'm going to simplify that fraction. So this is 1 over sine squared x, and I'm just going to go ahead and multiply it by the reciprocal. And you see that these two simplify, so I'm left with 1 over cos squared x. All right, now I have sec x and cos x. So this one's a little bit trickier. I know that sec x is equal to 1 over cos, and we're subtracting cos x here. Now I can't leave a fraction. I have to put these together. So let's remember our rules of fractions. I need a common denominator. In order to get a common denominator, my common denominator is going to be cos x. So I need to multiply both top and bottom by cos x to get the common denominator. So I'm left with 1 minus cos squared x, because that's the result of those two, and that's all over cos x. But if you take a look, this and this have some things in common here. I can rearrange this identity. If you just look up at the top left here, if I subtracted cos squared x from both sides, I would end up with sine squared x is equal to 1 minus cos squared x. So as you can see, this is the same as this. So I can replace that with sine squared x, and I'm going to leave the cos x on the bottom. So that would be my simplified version. All right. I'm going to go through class example number 4. I have sine squared x over cos squared x. And the question is asking me to express each as a single trigonometric ratio. Let's see if I can bring this down here. There we go. Just handier to refer to it on the side. All right. So I know sine squared x over cos squared x is actually equal to tan squared x using this identity. When I see that tan squared x plus 1 is equal to sec squared x. So now we have expressed it as a single trigonometric ratio. If you would have put it this way, it also would have been correct. So these are your 2 correct answers here. Now let's take a look at this one. I have sine x plus cotan x times cos x. Well, the first thing I'm going to do, and this is often what we do when we go to proving identities. Right now we're just simplifying them, but eventually we're going to prove them. I'm going to get rid of any tan or cotan when it's surrounded by sine and cos. So I'm going to write this as sine x plus, and if you take a look here, my cotan x is equal to cos over sine. So I'm going to turn that to cos x over sine x, and this is times cos x. Follow the order of operations. I'm going to do the multiplication first. When I multiply fractions, it's straight across. So that becomes cos squared x over sine x. Now I have a fraction, so I'm going to put them together by finding a common denominator, which is going to be sine x. So I need to multiply both top and bottom of the fraction to keep the equivalence. So I have sine squared x plus cos squared x all over sine x. And if you look at your identities, grab a different color here, we can see that this is the same as this, so I'm allowed to replace it with 1. So my answer is 1 over sine x or cosecant x. Because the question asks as a single trigonometric ratio, those would both be suitable answers. All right, now get rid of this, clean it up a little bit. Which is not an identity? Well, I can see that this is equal to this. So that's an identity. And if I rearrange this one, I get this one. So it is also an identity. And if I go tan x times cotan x, I know that cotan x is equal to 1 over tan x. And I know that's true. This is not true. Those both have to be squared in order for that to be an identity. So B is not an identity, and the rest are. I'm going to give you a chance to try class example number 6, and then I'm going to come back and do it for you.